After careful examination of the customer's marine auxiliary needs, we based the 6EY18 on two core development concepts. First, raising the life cycle value of the product. That means to maintain reliability and durability for a lifetime in fully operating ships and make a significant and lasting difference to peace of mind and cost saving. Second, developing a product that works in harmony with the global environment. YANMAR meets customer needs with care, and the wisdom of the whole group is pooled in the innovative development processes that enhance life cycle value. Raising life cycle value for our customers was a comprehensive effort of not only the development division itself. Full use was made of 3D CAD design as a common tool, with plenty of input from production, marketing, and servicing too. The new turbocharger, ring grooves, and other new technologies were first assessed and verified for life cycle value in the preliminary tests. We checked the quality, performance, functions, and durability through repeated onboard and various elemental tests. The 6EY18 is a tried and tested package of new technologies you know you can trust. Development tests were also implemented at the Amagasaki plant. We produced two prototype engines. On one, we tested general engine performance. We coupled the other with a generator and tested the durability, reliability, load input, and other aspects of generator engine performance. We tested the performance, temperature, and stress of such major items as the cylinder block, cylinder head, and cylinder liner, and moving parts such as the connecting rod, piston, and crankshaft to verify the reliability. In the durability tests, we conducted many hours of continuous operation at 100% load to check that there was no problem with the durability of any part. We reproduced onboard operation with our heavy fuel oil and checked the reliability of the engine for marine auxiliary use, combustion chamber contamination, and parts wear. When an engine is operated at low load on heavy fuel oil, it is common for the combustion chamber to become contaminated. In order to prevent that, we introduced a low-sack fuel injection valve and other new technologies. Thanks to these, the cylinder head, piston, and related components stay clean. The environmental performance requirements for engines have grown very tight. The research and development on engine technologies that address environmental issues is performed at YANMAR's Research and Development Center. A prime example is YANMAR's own assigned combustion system. By distributing fuel mist with extreme precision through the combustion chamber, Assign makes it possible to achieve both low fuel consumption and low NOx emissions without raising combustion pressure or fuel oil injection pressure. This system is used, of course, in the 6EY18. We research and verify test engines by computer simulation of the electronic controls and new intake and exhaust systems in order to develop and market engines that are friendly to the environment. The cylinder block is strong and rigid, with a hanging bearing structure and optimized cylinder partition wall. The cylinder block houses the charging air chamber, lube oil pipe, and cooling water piping to realize a pipeless design. The crankshaft is alloy steel forged to support the high cylinder pressure. The 12 balance weights maintain the thickness of the oil film on the crankshaft. The connecting rod is carbon steel forged and has a diagonally split large end. The piston is an FCD single piece. It has an anti-polish ring that mitigates liner wear and reduces lube oil consumption. The cylinder head is hydraulically tightened for reliability with extreme cylinder pressures. The intake and exhaust systems are placed on the non-operation side. This is convenient for inspection and servicing and helps in disassembly. The auxiliary equipment is concentrated on the non-operation side for the ease of routine inspection. The newly introduced MET 18 turbocharger has a long maintenance interval. The lube oil filter uses the automatic backwashing system. No element replacement is required, and it's practically maintenance-free. The intercooler has a module structure. It is integrated with the turbocharger installation mount. The intercooler has a twin core. Each core can be extracted in either direction for convenient maintenance. Piping joints are concentrated at the front. This reduces the number of staff hours spent on piping work while on board. To reduce piping, the thermostat for special use with the freshwater dual mixing system is coupled directly to the engine. Both fresh and seawater cooling systems are available. The engine is flexible for various applications, including the use of a fuel oil feed pump. The fuel oil piping is simplified and the fuel injection pump case sealed by a cover. This prevents the onboard fire hazard of splashing fuel oil. The main specifications of the new 6EY18. The new engine has 6 180mm bore cylinders. This table shows the generator capacities for use with the 6EY18 engine. As compared to our conventional engines, the 6EY18 covers a wider range of generator capacities. The new marine auxiliary engine, the model 6EY18. It is a crystallization of Yanmar's diesel engine manufacturing technologies. It is based on the two core concepts of raising life cycle value and harmony with the global environment.